Okay, welcome back. Now, I'm going to do this example. I already filled out the table, so just to save some time in the video, because I know you guys can do this yourself. So in this example here, we're given these two parametric equations, and we want to sketch the graph of this thing using the parametric equations. Now, what they also want us to do is also graph it using the rectangular equation, right? And graph it on the Cartesian plane and then compare the two graphs. Now I'm going to say right now that you're going to get the exact same graph as you would on either graph. Now the only difference is we're going to have directional arrows when we graph it on the polar, or not the polar, but on the using parametric equations. Okay, so what I did was I just plugged in all the values of t from -5 to +5, and I just plugged in those values into cosine and sine respectively to get x and y from these equations. And so these are all approximate values. Why? Because again, you're using your calculator, and the only one that's not approximate is at 0, because at 0 cosine is 1 and sine is 0, so you get 5, 0. The rest of these are approximate values based off the calculator, rounded to 1 or 2 decimal places. Okay? So, now I'm going to plot some of these. First of all, I'm going to plot at 0 at 5, 0, which is going to be right about there. At -5 seconds, at -5 seconds, we are at 1.4 and 1.9. So 1.4 and 1.9. So approximately there, I guess. The next point is -3,3, 1.5. So -3,3 and 1.5. So let's say about right here. And then at -3, we're at approximately -4.95 and -0.28. So -4.95, so that's probably right about here, and -0.28. So let's say about there. And then at -2 at t equal to -2, we're at -2.1 and -1.8. So -2.1 and -1.8. So let's say we're right about there. And then at -1, we're at 2.7 and -1.7. So we're at 2.7 and -1.7. So let's say we're right about here. And then we're at 5, which is right there. And then at 1 second, or excuse me, t equal to 1, we're at 2.7, 1.7. So we're at 2.7, 2.7 and 1.7. So let's say right about there. And then at 2, we're at -2.1 and 1.8. -2.1 and 1.8. And if we keep plotting, so -4.95 and +2.8. So now we're right above here now. And this is at negative 3.3 and negative 1.5. So now we're here. Hold on. Yeah, maybe this should be down a little bit more. And so this one's going to be like so. And then the last point, 1.4 and negative 1.9. Is like that. Okay. So in other words, what's going on here is as we go from negative 5 to 5, we've actually gone around, let's say, twice. So it's going to go, and then 5 is going to be right about here, right? This is about 5. So this is an ellipse, right? Oops. It looks like that. And notice that, again, using the rectangular plane, we know that the major axis is going to be in the x direction, goes out 5, 5 and 5, right? This is centered at the origin, and 2, right? So right there, 2, so not bad. So there's 2, so we know it's going to intersect at 2 and 5 and 5, okay? And that's it. Oh, the direction. It's going this way. Always want to put your directional arrows. Okay, have a great day.